Hello everyone. Today we will solve an equilibrium problem. Here the problem states in figure 35, which is this one, the bodies A and B connected by a cord and resting on smooth planes weighing weight of A equals 50 pound and weight of B equals 30 pound. The body A is acted on by a force in such a manner that the tension in the cord is 20 pound. If the normal reaction between B and the plane is 25.98 pound, what is the resulting force on B? So let's start by finding the free body diagram. So let's draw the free body diagram of B. We can write FBD of B. Here the weight of B, will pull it downward, and which is 30 pound. And then there's a normal force or normal reaction of the plane under the B object. So it will push it a 90 degree upward from the surface. So it will be theta angle with the vertical axis. Then we will get 25.98 pound, and then we can write the tension in the cord. Here the tension in the cord is said to be 20 pound, and we know that a cord on a smooth surface is about the same tension in both directions. So we can take it this way. The tension would be 20 pound, and the angle would be theta degree. Here we have to find the reaction on the B. For that we don't know if it's in equilibrium or not. So for that we will take an arbitrary reaction which will keep it in a equilibrium state. Let's take it downward on the slope. So it would be this way, and we can name it R prime, and the angle would be theta with the horizontal surface. So let's find the value of theta, because we don't know the slope's angle. So let's find out. Here summation of f of x, where rightward is positive, equals 0. Then we get minus 20 cos theta for this one, and then plus 25.98 sin theta for this one, and then plus R prime cos theta for the resultant, equals 0. Then we can write R prime cos theta equals 20 cos theta minus 25.98 sin theta. So the r prime would be 20 cos theta by cos theta minus 25.98 sin theta by cos theta, or we can write r prime equals 20 minus 25.98 tan theta, because sin theta divided by cos theta equals tan theta, and we can take it as equation 1. Then let's find out the summation of f of y. Here the upward is positive, equals 0. Then we get 20 sin theta, which is this one, plus 25.98 cos theta minus r prime sin theta, and finally the weight of it, which is directly vertical downward, so we can take it as just 30 equals 0. Then we can write r prime sin theta equals 20 sin theta plus 25.98 cos theta minus 30. Then we can write r prime equals 20 sin theta divided by sin theta plus 25.98 cos theta divided by sin theta minus 30 by sin theta. Thus we can write r prime equals 20 plus 25.98 cot theta as cos theta divided by sin theta equals cot theta minus 30 cosec theta. And here we can mark it as equation 2. Here is an important note of this math, because we have to take it the r prime as an angled force, because if we don't pick it this way, we can find the value of the summation in f of x or f of y into this format. Because if we took it as a horizontal force or a vertical force, then it would miss either f of y or f of x summations. Thus we can't create a equation like this, so we have to take it in an angled format. So let's solve these equations, because we can see that equation 1 is the equation of r prime, and then equation 2 is also an equation of r prime. So we can write equation 1 equals equation 2. So we can write 20 minus 25.98 tan theta equals 20 plus 25.98 cot theta minus 30 cosec theta. And if we pull all the trigonometrical values in one side and just the numeral values to the other side, then we get here 30 cosec theta is in negative, so we will get it as positive 30 cosec theta minus 25.98 cot theta, and then minus 25.98 tan theta equals, there we get 20, and this 20 here is in positive and it will be in negative. So then we get here, if we break it down, we get 30 into 1 by sin theta minus, if we take 25.98 as common, we get 25.98 into, and if we write it as cot theta in cos theta by sin theta minus, it will be plus, not minus, we will get sin theta by cos theta equals 0. Then if we write it down as here like this, 30 by sin theta minus 25.98, and in the bracket we get sin theta into cos theta, then we will get cos squared theta plus sin squared theta. Equals 0. Then we get 30 by sin theta minus 25.98 into, we get 1 sin theta cos theta equals 0, as cos squared theta plus sin squared theta equals 1. Here we get this type of situation, and then we can do it like this. If we take 1 by sin theta as common, we get 1 by sin theta into 30 minus 25.98 divided by cos theta equals 0, or we can write 30 minus 25.98 by cos theta equals 0, as if we send the sine theta to the other side, it will be multiplied with the 0 and the result would be 0. And if we write it as (25.98) cos theta equals 30, then we can write cos theta equals 25.98 by 30, or we can write it here as theta is equal to cos inverse 25.98 by 30. Therefore theta would be cos inverse 25.98 divided by 30, we get 30 degree. So everyone, here we have found the value of theta. Now the math would be easy as the previous ones. So let's focus on that. For that, we can take any of the f of x and f of y without the resultant which we took for making it equilibrium, because the problem didn't state that the situation is in equilibrium, so we will solve it in the regular way. So we can write summation of f of x. Here it would be rightward positive equals, we can take it as minus 20 cos theta. Instead of theta we will write 30 degree, then we have plus 25.98 sine theta, we will use that, plus 25.98 sine 30. So then we will have a summation of f of x which would be minus 20 cos 30 plus 25.98 sine 30, then we get minus 4.33 minus 4.33 pound. And for the summation of f of y, where upward is positive, we can take the equation from here and avoiding the r prime which we don't need anymore, so we can write 20 sine theta, 20 sine 30 degree, because the value of theta is 30, and then plus 25.98 cos theta plus 25.98 cos 30 degree, and then minus the weight of the object B, so it should be 30. Then here we can find the value of summation of f of y, which is 20 sine 30 plus 25.98 cos 30 minus 30, which would be 2.499. So we will write 2.499 pound. So the resultant would be R equals root over summation of f of x whole square plus summation of f of y whole square, and if we put the values in, then we get minus 4.33 whole square plus 2.499 whole square. We get 4.33 whole square plus 2.499 whole square, and then root over answer we get 4.999 pound, or we can say 5 pound, which is the resultant. And the angle of the resultant, we can guess it from the value of f of x and f of y, because the f of x is in negative and the f of y is in positive, so the resultant would be somewhere along this line. And if we want to find the angle of it, then we can find the by tan theta equals summation of f of y divided by summation of f of x. Our theta is equal to tan inverse f of y was 2.499, and then f of x was 4.33. So this value would be tan inverse 2.499 divided by 4.33, and we get 29.99, or we can say it's roughly 30 degrees. So from this we can say that the resultant is 5 pound and the angle of the resultant would be 30 degree, so it would be along the slope, because we have found that the theta of the slope, or the angle of the theta, which was unknown, we have found it as 30 degree. So that's it for this math. Thanks for watching.